You're standing on the rusty red dust of Mars, staring at a horizon that curves too sharply, with a sky that's always the wrong color. But could you actually survive here, breathe, eat, endure the relentless assault of an alien world? Science is painting a clearer picture than ever, blending brutal realities with groundbreaking innovations that might just make it possible. Strap in, because we're exploring if humans could hack it on the red planet, backed by the latest data and a glimpse into a future that's closer than you think. This is Could You Survive on Mars? What Science Says. Let's confront the brutal truth head-on. Mars is a death trap designed by nature itself, a world that seems engineered to repel life. The core problem: it's not built for us. Start with the air or lack of it. The atmosphere is razor-thin, about 1% of Earth's pressure, mostly carbon dioxide, which means stepping outside without a suit would cause your blood to boil in seconds from the vacuum-like conditions. Temperatures swing wildly, averaging -80 degrees Fahrenheit, plunging to -200 at night, freezing any exposed skin or equipment. Then there's gravity, just 38% of what we're used to, which could waste your muscles and bones over time, turning a fit astronaut into a frail shadow. But the real killer is radiation without a magnetic field or thick ozone layer. Cosmic rays and solar flares bombard the surface at levels 40 to 50 times higher than on Earth, raising cancer risks and scrambling DNA. Add in toxic soil laced with perchlorates that could poison water supplies or inflame lungs, and pervasive dust storms that blot out the sun for weeks, crippling solar power. These aren't hypotheticals. They're facts from decades of probes and simulations, showing why no unprotected human could last more than a minute on the surface. If we ignore these, any mission becomes a suicide run, stalling our dreams of expanding humanity's reach. Yet, understanding this cosmic gauntlet is the first step to beating it, fueling urgency to innovate before we risk lives on a one-way ticket. Shifting to today's landscape, the current state of Mars survival research is a mix of daunting challenges and exhilarating progress, with 2025 marking a pivotal year in our understanding. Probes like Perseverance have drilled into the planet's secrets, recently uncovering a rock with potential biosignatures, organic molecules, and signs of ancient water flows that hint at past microbial life, suggesting Mars wasn't always this hostile. This isn't proof of aliens, but it underscores the planet's watery history, with vast ice reserves buried under the soil that could be mined for drinking water and fuel. Engineers have tested this in real time. A device on Perseverance split CO2 into breathable oxygen at rates double initial goals, producing enough in tests to sustain a small dog paving the way for larger systems that could support crews. Radiation remains a beast, but solutions are emerging. Materials like hydrogenated boron nitride nanotubes, which absorb neutrons and shield against cosmic rays, are being prototyped for suits and habitats, potentially cutting exposure by half. Underground living is key. Lava tubes, natural caves from ancient volcanoes, for built-in protection, with walls thick enough to block most radiation while stabilizing temperatures. Gravity's toll is trickier, but analogs on Earth, like bedrest studies, show we can counter it. Resistance exercises and drugs like bisphosphonates have preserved bone density in simulations, limiting loss to under 5% per month. Food production. Greenhouses using aeroponics, growing plants in mist without soil, have yielded crops in Mars-like conditions, with LED lights mimicking sunlight to boost yields by 25%. Power is solar's weak spot due to dust and low light. Mars gets only 43% of Earth's sunshine, but nuclear reactors, compact and reliable, are advancing. Prototypes tested in 2025 could generate steady energy for years without refueling. Psychological hurdles loom large. Too isolation in confined spaces can spike stress, but virtual reality therapies, proven to reduce anxiety by 35% in long-duration simulations, help crews stay sharp. On social platforms, experts debate these hurdles. Some highlight how perchlorates in soil could disrupt hormones, while others point to AI analyzing vast datasets from rover missions to predict dust storm patterns with 90% accuracy, outpacing human forecasts. Skeptics argue we'll never fully mimic Mars on Earth, but these tools simulating complex outcomes from radiation exposure to crop failures give us an edge, turning raw data into survival strategies that no other era could match. Peering ahead, the future implications of cracking Mars survival are revolutionary, blending human grit with tech that could redefine our species. If we master this, space becomes our backyard. Colonies on Mars could serve as backups for Earth, safeguarding against disasters like asteroids or climate shifts. Energy innovations like zero-point systems, drawing from quantum fluctuations, might power habitats indefinitely, as equations suggest feasible extractions without cosmic fallout. Health tech evolves too. Neural implants, building on 2025's brainwave scans, could regulate fear responses during isolation, boosting mental resilience by 40% in analogs. Analyzing petabytes of genetic data, AI might engineer radiation-resistant cells, simulating outcomes to predict mutations with 95% accuracy, curing space-related ills before they strike. Urgency builds what if delays mean we miss windows for sustainable settlement? Optimistically, it unites us. Shared habitats foster global cooperation, solving earthbound crises like food scarcity through Mars-proven aeroponics, yielding 30% more crops in harsh climes. Logical closed-loop systems, inspired by string models, ensure self-sufficiency without paradoxes, recycling air and water at 99% efficiency. Yet, inequalities lurk. If only elites access this tech, it widens divides, but democratized AI could level the field, modeling scenarios for all. Skeptics doubt timelines. Full colonization by 2040 seems stretchy, but 2025's rover biosignatures and reactor advances hint we're reaccelerating, propelling human progress towards stars. For a speculative scenario that'll leave you breathless, picture 2050, where you've volunteered for the first permanent Mars outpost. You descend in a Starship variant, its heat shield glowing against the thin air. Touchdown in Hellas Basin, the deepest crater, where pressure's slightly higher, easing suit strain. Your habitat, a cluster of inflated modules buried under regolith for radiation shielding, walls laced with boron nanotubes blocking 80% of cosmic rays. AI oversees everything, analyzing soil for perchlorates, purifying ice into water at 10 gallons daily, and optimizing aeroponic farms yielding fresh veggies in weeks. Gravity's low, so you strap into centrifugal gyms, spinning to mimic Earth's pull, preserving bones with minimal loss. Conflicts arise, a solar flare hits, spiking radiation ice seals sectors, simulating evacuations from vast datasets to minimize exposure. A rogue dust storm buries solar arrays, but nuclear microreactors kick in, drawing endless power. Society adapts, screws rotate in dilated shifts, minds linked via neural nets for empathy, diffusing isolation blues. You farm, explore lava tubes teeming with ancient water signs, even detect microbial fossils echoing 2025's rover finds. Rogue elements emerge. A faction hacks AI, amplifying fears to seize control. But you counter with empathy protocols, rewriting code in real time. Vacations, virtual dives into Earth simulations, weeks of home in hours. Families thrive across generations, histories alive in shared data. Or deepens, realizing Mars' harshness forged our resilience. Perhaps we're already echoes of cosmic survival, breakthroughs unlocking multi-world potential. This isn't fantasy, it's extrapolated from 2025's oxygen tech, radiation shields, and AI simulations, igniting curiosity about our stellar destiny. Pulling back, the real question isn't just surviving Mars, it's thriving beyond Earth, turning science into our shield against the void. From radiation barriers to AI guardians, each step unites us in wonder, pushing human progress to new frontiers. This journey's for all, demystifying the cosmos one fact at a time. Comment below, could you hack Mars life, yes or no? What scares you most about it? Share your survival tips. If this fired your imagination, hit like and share with a space dreamer. Subscribe, ring the bell for more cosmic deep dives. Let's conquer the stars together. Stay curious, keep exploring.